So here I have opened the Ansys Electronic Desktop 2020 R1. Basically, the Ansys Electronic Desktop is a combination of different tools used for electronic and electrical design. So if I click on the new over here, I'm going to basically create a new project. So the moment I click over new, all these points are going to get activated, where I can see open example, save as, or close, and other examples. What I'm able to see over here in the menu is HFSS, Q3D, Circuit, IcePack, Maxwell, and Simplorer. So these are the fundamental tools which are embedded into a common package known as Ansys Electronic Desktop. And here there are other options as well, where you can get the help and you can configure this GUI from general options. So what are these different packages included in the electronic desktop? So here is HFSS, here is Q3D. Basically HFSS and Q3D are for high frequency design, maybe for example an antenna design. Circuit is basically you can create your schematic. The IcePack is basically the thermal analysis of electrical and electronics, and it can be applicable to the printed circuit boards as well. Maxwell is fundamentally the electromagnetic software. So Maxwell 2D, 3D, and Maxwell circuit and RM Expert is what we are going to start with now. Simplorer is basically a tool where you can do the multiple domain analysis. So let's start with the Maxwell and let's open the fundamental tool over here, which is RM Expert. So here I'm going to open the RM Expert and let's see how we can jumpstart our motor design. So when I click on the RM Expert, this will ask for the motor type, and you can see here there are many different types of motor listed over here, and you can choose any from here. So if I get RM Expert solution and a standard machine type, then this menu will get activated and I can decide which motor I want to start with. So let us start with a permanent magnet DC motor. So basically the permanent magnet DC motor is the most simple version of any motor, and let's start the design. So this is going to create a project over here in the project manager, and this project manager will show the different parts of this project. And what are these different parts of the project? Here is the first machine and stator. If you expand the options, you will find the stator, rotor, commutator, shaft. These are all the components or the constructional parts of the machine. Now, how to jumpstart our design? So basically you can double click on the machine and you can decide whether you have how many number of poles you have. So let's say 2 is the default value. Let me keep it as 4. So we have 4 number of poles, and our reference speed may be let's say 2000 number of RPMs. I need to basically work out a math in order to determine all these values. I'm going to just assume some values in order to explain how RM Expert tool works. So here is the stator. If I double click on the stator, I can decide on the outer diameter. Let me decide it to be 80 mm. The inner diameter of the stator is basically, let's say 60 mm. The length is 100, and we can actually assign the material as well. I'm not going to assign it now. I'm going to just create the geometry of the stator. So here is the green color geometry of the stator which we have, and on that we can actually add permanent magnets. So if you add the length of the permanent magnet, let's say it's 5 and thickness is 2, basically we are going to add 4 pole permanent magnets over stator like this. Now I can click on the rotor and I can decide about number of slots. Let's say they are 14. Outer diameter, I need to keep in mind about the stator outer diameter. Let me check on that. What was the number I fit in? So the inner diameter of this stator is basically 60. So my outer diameter of the rotor should be less than 60. And let me keep it as 55. I'm assuming the air gap of 5 mm. It may not be the right guess. Let me keep it as 2 mm air gap. And the inner diameter I'm taking is at 20, and I'm assigning the length as 100, and I can assign the material over here, and I can choose the slot type as well. So what is the design of the slot which we want to develop? So if I select 4, then it can be like this. So if I do apply and OK, then this is the geometry of the rotor which is developed, right? So if I click on the machine, now here basically what you are able to see is the motor develop, which is a 4-pole permanent magnet DC motor. Now basically we need to develop winding over here, and we can do so by actually providing this winding data, and if we fill in all these values, we can actually create the slots and tooth arrangement on the rotor. So this is going to be a wound rotor and permanent magnet stator kind of an arrangement. So this is the arrangement, and this is how quickly you can develop the geometry. You can assign the material and you can start your analysis. Because I haven't entered all the values for creating the slots, let me open the example for permanent magnet DC motor. How do I open the example? Let me close this first. So I'm going to click on the desktop here. Here you can see there are 4 options: desktop, view, simulation, result, and automation. So these are the 5 options which you can use for quick change of the view. So if I go to desktop and click on close, then I can actually close the standard design, and now I can open the example. So when I open the example, this will actually go through the installation directory, and I can decide on RM Expert folder, and inside RM Expert these many number of designs are present. So let me open the PMDC, and the PMDC one is available over here. So now I am able to open the permanent magnet DC motor, where it's a 2-pole motor, and there are number of slots and tooth arrangement where the winding will be over here inside the slots. So this is the configuration which is already present, and this is the fundamental permanent magnet DC motor. And let's see this example. What are the details given over here? So if you click on the pole, basically the magnet type or the material of the magnet is defined over here. If I click over here on the magnet type, I can actually understand what is the magnetic material I'm going to use for my motor. So if I click over here and basically see this XG196/96 is a RM Expert origin magnetic material, and I can basically go to view and edit material over here, and I can click on the BH curve in order to understand about what is the type of this permanent magnet. So if I see this BH curve, here on the y-axis we have B in Tesla, and on the x-axis we have H in amperes per meter. So this is the BH curve for the permanent magnet, and basically it is the combination of B and H values, and you can actually add and amend those values, and you can actually swap X and Y data over here as well. So there are multiple options, and you can actually change the unit of B and H values as well over here. So if I click on cancel, and go back to the material, so here these are the parameters which are entered over here. Most of the values are 0 because it's a default material in the library. So where are all the materials? So in order to see the materials available, I need to select all the libraries. So right now we have selected only project definitions, but we can actually select all the libraries. So when I click on select all the libraries will be included over here, and we will be able to see many such systems. So for example, there is Arnold Magnetics, China Steel, and these are basically the material manufacturers for motors. You have Granta, you have Hitachi Metals, and so on. So these are all the materials available, and if you scroll down through this, there are a whole lot of materials, and I can basically categorize them according to the steel, according to the conductor, and the magnet. So if I click on the type over here, I can make a short list of all types similarly. So here we have all the steels, and then going below we have all the magnets, and basically you can see their characteristics, and you can go to view added material, and this represents the BH curve of manufacturer's datasheet. So the Ansys supports a wide range of material library, and there are many built-in materials which are used for your reference. Now in case of your material which is not fitting into this, right, or you are not using any standard library, you can basically add your material definitions as well. So it's quite easy to add your own material characteristics and then use it for the analysis. So this is about the material library, and you can see there are basically 3 categories, where it's magnet and steel and the conductor. So whether it's a core material or the winding material, both are available over here. So this is about the material library, and you can basically filter it out and do the quick analysis for materials over here in this window. And so let me cancel this, and let's keep the default values. So this is about the material. And similarly, if you go to the rotor, the rotor steel type is also defined over here. So if I go to rotor steel type and see the BH curve for that, I can see that curve for core material as well. So this is the core material for the rotor core. It's basically the steel, and the BH curve for that is available over here. So let me go back and cancel this, and probably I opened many windows, but I think you can configure the material type when you double click on the different parts of the motor. So similarly, you can decide about the commutator design, where it's type of the commutator, the diameter, length, and the insulation thickness. So once this is available, you can actually go to the analysis and run the analysis in the RM Expert, and it is going to quickly come to the results part because it's just an analytical calculation. So let's do the analytical calculation for one of the example, and let's try to understand what are the results. So in order to do that, I'm going to now choose permanent magnet synchronous motor. So let me close this. I'm going to close this and open another example for permanent magnet synchronous motor. So permanent magnet synchronous motors are here actually named as adjustable speed synchronous motor. So if I open this, I can select the adjustable speed synchronous motor, and I can see the design of permanent magnet motor. So here is the design template readily available. Let's not modify anything, and let's try to run the setup. And if you see this, you can basically zoom in and you can see what are the things available over here. You can actually have a look at the slots and the winding, and basically the winding configuration is also done available over here. So the difference of the coil in terms of number of slots is 5, and you can see the parallel number of branches are 1. The conductors per slot, there are 52 numbers of conductors. Here you can decide about the wire size as well. So if I basically right click over here, I can actually connect all coils and try to see how these coils are connected. So this coil 1, 2, 3, 4, 5, 6 are representing the different phases. So here you have the in slot number and the out slot number, which are indicated over here, and the A, B and C are the 3 phases of the motor. So I can disconnect the coil over here, and I can just enable the connection of one phase alone. So this is the connection for A phase, and basically if you see, the A phase winding starts from this part, and basically after 5 number of slots, 1, 2, 3, 4 and 5, this wire is connected to this wire. So basically the coil pitch is 5 number of slots over here, and which we have seen already in the configuration. Here the coil pitch is 1, and you can decide about the coil pitch, and you can actually configure your windings as well, and you can see the winding patterns available over here. And you can basically select the type of the winding, whether it's a whole coil or half coil, or you can make a user defined winding as well. So these are the options available. And if you want to see the rotor alone, basically this is the rotor, and as we have seen, this is surface mounted permanent magnet motor, and we can actually configure this machine in a lot of different ways. So let me explain you how we can configure this machine into let's say outer rotor motor. So I'm interested to configure this machine as outer rotor motor. I need to change the rotor position to outer rotor. So if I click over here and choose the outer rotor and click apply and OK, this is going to change the orientation of the slots, right? So earlier the slots were available on the inner periphery of the stator. Now they are available on the outer periphery of the stator. So how do I make outrunner motor or outer rotor motor? I need to change the dimensions of the rotor now. How do I change the dimension of the rotor? I need to first check the dimension of the stator. So basically the stator outer diameter is 120 mm and inner diameter is 75 mm. So I need to keep in mind about 120 mm as outer diameter, and then I can double click on the rotor, and the outer diameter can be 121. The inner diameter can be 121, and this can be 140. So if I do like this, keeping all other parameters same, then this is going to be configured as the outer rotor motor. And if you zoom in over here, basically you will be able to see the configuration of the stator winding is like this, and the rotor is outside, and basically this can be fitted into a wheel, and I can actually configure the rotor part, right? So if I change the rotor pole type and the thickness of the rotor magnet and the embrace and the offset, I can actually configure my outer rotor motor as well. So the outer rotor motor usually preferred for low power vehicle application. And let me go back to presentation and show you one of the outer rotor motor.